I drink liquor on liquor, I had women on women, yeah, that's bump bad bitches. I done live more than an 80-year-old man still kicking, cause they live for some.
So let's say we have limit as x goes to 2 of x squared plus x minus 6 over x squared minus 4. Okay, so if, I'll just do this for demonstrative purposes, so if you immediately, like right off the bat, if you immediately plug in a 2, plug in 2 for x, this is what we'll get. So this is going to be equal to 2 squared plus 2 minus 6 over 2 squared minus 4, which the top is 4 plus 2 minus 6 is a 0, and on the bottom we have a 4 minus 4, so that's a 0. So this here is what's called an indeterminate form, okay? So what we have to do is kind of play around with this formula, our f of x, okay? So this is our f of x. That's what we're going to play around with to see if we can get it in a different, more workable form, I guess, that doesn't give us this 0 over 0 at the end, okay? So let's rewrite the question. So limit as x approaches 2 of x squared plus x minus 6 over x squared minus 4. Okay, so what we can do here, I see a lot of factorable things, so we're going to rewrite this as limit as x goes to 2 of, and the top can factor into an x plus something and an x minus something. So the plus is going to be a plus 3, and the minus is going to be a minus 2 in order to get that plus 1 in the middle there, that plus 1x, okay? So we have that, and then the bottom can be factored into x minus 2 and an x plus 2. Okay, so here we see the situation where you can actually cancel something from the top with something on the bottom, right? Because it appears in both. So we can cancel out that x minus 2. All right, so in doing this, we are removing the indeterminacy. So now let's write what we have. So we have limit as x goes to 2 of x plus 3 over x plus 2. Okay, so now let's try plugging in our 2 for x, and let's see what we get. So we have a 2 plus 3 over a 2 plus 2. So this is going to turn out to be a 5 over 4. All right, and that is definitely not the same thing as our 0 over 0 before. So here we eliminated the indeterminacy by playing around with some algebra. Okay? All right, so that's the answer to that question, and now let's see another example. Okay, so here, what we're going to do is solve the following limit. We have limit as x goes to 4 of square root of x minus 2. That's on top. And then on the bottom, we have an x minus 4. Okay, so first of all, let's try the plugging in theory, or the plugging in method, first of all. So let's see, when we plug in a 4, we get square root of 4 minus 2 over 4 minus 4, which is going to turn out to be our 0 over 0, which is indeterminate, right? So we have to play around with this formula here. So let's see what we get. So this is limit as x goes to 4 of, and what we're going to do, so I'll rewrite it here. So what the process that I'm going to do now is called multiplying by the conjugate, okay? So I'll just write a little note, multiplying by conjugate. Okay, so what that means is that we're going to take, what we're going to do is actually rationalize the numerator, okay, because we want to get rid of this square root here. Okay, that's what we're aiming to do. So we're going to multiply by the conjugate, which means you have the same terms. So we're going to copy down the square root of x and the 2, okay? But we're going to change the sign before the constant number. Okay, so that'll be, instead of a minus, it'll be a plus. Okay? And then we're going to multiply both top and bottom by this conjugate. So it's like we're multiplying by 1, right? This is just 1. Okay? And then now let's see what's going to happen. So here's where the magic comes in. Sort of, the magic of math. So if we FOIL this out, what we get is an x. This is the difference of two squares, right? So this is actually going to come out to be an x and then a minus sign and a 4, I believe. Okay, so we have that there, and then on the bottom, what we're going to have is an x minus 4 times this square root of x plus 2. Okay, so as you can see, now on top and bottom, what we have is an x minus 4, which we can cancel out. Okay, and then so what we get is a limit as x goes to 4 of 1 over square root of x plus 2. So at this point, we see that this form of our f of x, because remember this is the same thing, the thing I just circled here, this 1 over square root of x plus 2, that is the same thing as what we started with. I just changed it around a little bit by doing a fancy multiplication by 1 here, and then canceling some things out. So anyways, this is just a different form of f of x, and which happens to be continuous at x equals 4. So that's good. So because it is continuous at x equals 4, we can plug that directly in. So we get 1 over square root of 4 and then plus a 2. So this turns out to be 1 over 2 plus 2, which is equal to 1 over a 4. Okay? Alright, so again, here we multiplied by the conjugate, just some terminology. And what we also did is rationalize the numerator. Okay, so if you were to have a some kind of square root thing on the bottom, on the denominator, and then you wanted to multiply by the conjugate, then all you would do is, it would be called rationalizing the denominator, likewise. Okay? Alright, so now here's an example. Well, okay, I'll just write it and I'll tell you as we go along. So limit as x goes to 2 of x squared minus x plus 5 over x minus 2. Okay, so what we have here is that let's see what we have if this is our f of x, right? So this is our f of x. Let's see what happens if we plug in a 2, this 2 here, okay? Let's do that directly. So we have 2 squared minus a 2 plus 5 over 2 minus 2. So it looks like we're going to get one of those indeterminate forms again, right? So 4 minus 2 plus 5 over 0. But instead, on the top, we get a 2 plus 5. So we get a 7 over 0. And this here, because we have this 7, that makes it not an indeterminate form. So not an indeterminate form. Okay? Form. So what that means is that, because this isn't of the form like 0 over 0, infinity over infinity, infinity minus infinity, so it doesn't deal with just zeros and infinities, basically. So what this shows, because we have a 7 over 0, it shows that the limit itself, so the limit itself does not exist. DNE does not exist, okay? So the answer, the overall answer is going to be that limit as x goes to 2 of x squared minus x plus 5 over x minus 2, this does not exist. Okay? Alright, so that does it for the concepts video for evaluating limits algebraically. I hope that helped, and good luck on the homework.
It's Mars, never explaining the Mars. Devilish grin for my aliens who respond, peddling sin, thinking maybe when you get old you realize